Hello everyone, welcome to my YouTube channel The Learning Hub. In this video we are going to discuss about random forest as a classifier as well as for the purpose of regression. So before proceeding further in the detail of random forest, I suggest all of you that just watch the video of decision trees, and that is also named as a cart algorithm. Also, you should go through the numerical problem of decision tree solution that is available on my YouTube channel. Because we random forest is based on decision trees. It is using a combination of decision trees. So just go through that video once before proceeding with this. You should know the concept of entropy as well as the concept of information gain and how the decision tree works. So for that, just watch the other videos with decision trees available on the channel. And if you have not subscribed the channel yet, do subscribe the channel so that you don't miss any such important topic that is the prerequisite of a topic. So for delaying further, without delaying further, let us start with the concept of random forest. So random forest is a commonly used machine learning algorithm that combines the output of multiple decision trees to reach a single result. Rather than relying on a single decision tree, it is working on multiple decision trees. Just like in ensembled learning, we combine multiple models for providing a solution to a problem. It is using multiple decision tree for making the decision, and all the results are combined into a single result. Its ease of use and flexibility have fueled its adoption as it handles both classification and regression problems. It is a classifier that contains a number of decision trees on various subsets of the given dataset and takes the average to improve the predictive accuracy of that dataset. Since the random forest model is made up of multiple decision trees, it would be helpful by describing the decision trees briefly and also the limitation of the decision trees. So we know that a decision tree is a tree-like structure in which we are having internal and external nodes, which is a cart algorithm. But there is a issue with the decision trees, that the decision trees are prone to the problem of overfitting. So if we want to avoid the problem of oversitting, and one more problem that occurs with decision trees are biasness. So to avoid these two problems, we combine multiple decision trees. So those multiple decision trees are combined and they form a technique that is known as ensembled technique. So that's why we call that the decision tree is based on the ensemble learning, where an ensemble is a random forest algorithm and predict more accurate results. So when we talk of ensemble methods, let's discuss briefly about them. So when we talk of ensemble learning, in case of ensemble learning in random forest, it is combination of multiple decision trees. So it means this is working to create a random forest. We have like decision tree 1, decision tree 2, decision tree 3, decision tree 4, and so on up to decision tree n. So the results from all decision trees are combined into a single result. So we are combining multiple models to give a result, and when we take the result from multiple models, it will give more accurate result than relying on a single value. What does it mean over here? Now suppose you want a solution to a problem. You asked from one person and you have taken the decision, like you want to go to a place which is unknown to you, to a very new place. So what will happen in that case? If you ask someone, that person will say this is the best place to visit. Fine. And the other person says this is not a good place to visit. So this is a condition of confusion. But suppose you had taken the result answer from one person and you have gone to that place, and at that time you realize this was not a place worth time and the time got wasted. So this is something like not 100% accurate answer. So what will happen in this case? Suppose you have planned to visit any place, fine, and you have asked n number of persons. Suppose 70% persons have given positive rating to that place and 30% have given negative rating. You will go with this 70% positive rating. It means more accurate result will come from more voting. So what we are using in this case, we are talking about voting. We have taken the result for doing something, decision for doing something based on multiple results rather than relying on a single result. So we have used the technology of voting. So that is what happening in ensemble learning. And random forest is nothing else. They are made up based on the result of ensemble learning, on which consists of multiple decision trees. So when we talk of this ensemble learning, we know that ensemble learning have two techniques. One of them is bagging, another one is bootstrap aggregation. So based on these two techniques, there is decision is to be taken. So when we talk of this ensemble learning, to brief up, we can say that ensemble learning methods are made up of a set of classifiers and decision trees, and the predictions are aggregated to identify the most popular result. The most well-known ensemble learning methods are bagging and bootstrap aggregation. So the random forest algorithm is simply an extension of bagging method, and it utilizes both bagging features with randomness. So bagging and bootstrapping will be there, but one more feature that is coming in its name itself is randomness of something. Means we will take the values, the attributes, or the records for those attributes at a random decision, not in a particular sequence, or there is no hard and fast rule to choose that. We simply take the decision based on we will pick the values with some random factor only, and that is how we create a random forest tree. So when we talk of random forest algorithm, they have three main hyperparameters in case of random forest, which need to be set before training. These including node size, number of trees, and the number of features sampled in this case. So as we can see in this diagram, there may be, this one is decision tree 1, suppose decision tree 2, decision tree 3, and these three decision trees are combined into a final result and summation has been taken. So all these features are taken from the random forest classifier and can be used for regression as well as for classification problem. Random forest algorithm is made up of a collection of decision trees, and each tree in the ensemble is comprised of data sample drawn from a training set with replacement. That replacement is known as bootstrap sample from that training sample. 1/3 of it is set aside as the test data known as out of bag sample, and it will come into a later use. The other instance that we have in this case is the randomness that is injected with the feature of bagging. So both bootstrapping and bagging are combined to pick on the features and taking the aggregations. So these are few benefits of random forest. The first one is reduced risk of overfitting. Decision tree run the risk of overfitting as they tend to fit all the samples within the training data. When there is a robust number of decision trees in a random forest, the classifier will definitely overfit, and it will model since averaging the uncorrelated features, and the problem of overfitting will occur, and when we take off random forest, overfitting problem will be reduced. So when we take off taking the aggregates from multiple decision trees, and we do in random forest, By that aggregating, averaging the uncorrelated trees will lower down the risk of overall variance, and the prediction error will be reduced, and the problem of overfitting will also be reduced in that case. Another key benefit of random forest is it provides flexibility. That the random forest can handle both regression and classification tasks with a high degree of accuracy. It is a popular method among the data scientists. Bagging also make the random forest classifier an effective tool for estimating the missing values, and it also maintains the accuracy when we are talking of a portion of data that is missing. Another advantage of random forest is to determine the feature importance. These random forest makes it easy to evaluate the importance of the variable and the contribution of the variable to the model. There are few ways to evaluate feature importance. There can be Gini index importance, mean decrease in impurity are usually the measures or parameters for measuring the model's accuracy. It decreases when the given variable is excluded from the list. The permutation importance and the mean decrease accuracy are also considered when we talk of giving the importance to the features. Now the challenges in the random forest. The very first challenge in this case that comes when we use random forest is time consuming process. Because the algorithms can handle large data sets, they can provide more accurate predictions, but they can be slow as well to process the data, as they are computing data for each individual decision trees. It requires more resources because the random forest processes larger data sets. They require more resources to store their data. This is also more complex that the prediction of a single decision tree is easier and interpreted when compared to the forest of them. Coming to the applications of random forest, it has applications in finance, healthcare, medical, e-commerce, marketing, and all such. Banking sector uses this algorithm for the identification of loan risk, and also the finance sector is in finance sector it is a preferred algorithm over others, that it reduces time spent on the data management and pre-processing tasks. It can be used to evaluate the customers with high credit risk to detect the fraud and option pricing problems. In healthcare or medicine, with the help of this algorithm, the disease trends on the risk can be identified. The random forest algorithm has applications with computationally biology that allows the doctors to tackle with the problems like gene expression and classification, biomarker discovery, sequence annotations, and many other problems. Doctors can make estimates around the drug response with the specific medications. Talking of e-commerce or marketing, it can be used for recommendation engines for a cross-sell purpose, and these trends can be identified using this algorithm. It can also be used for land use, where we can identify the areas of similar land by using this algorithm. So that's all about the basics or introduction of random forest. In the next video, I will be sharing the solution to the random forest problem and how the random forests are created. So thanks for watching the video.